Hello everyone. In this video, we will understand how do we find inverse of a matrix by using elementary operations. Question is, find the inverse of matrix A using elementary row operations where matrix A is given by this, right? So for the solution, first of all, we know that any matrix can be defined as the identity matrix of corresponding order into A. That is there, means it is like identity matrix or unit matrix. If I multiply with this matrix, I will get the same matrix. So based on that, we write that matrix A here, and then here we write that identity matrix, and then we write A. Now our idea is, if I could convert this this left hand side to an identity matrix, for converting it into an identity matrix, I need to do certain row operations to this matrix so that I will bring it to identity matrix. The same row operations I'll be applying it here also, so that when I land up with I in the left hand side, some matrix I will get here and I will get A. So we know very well that if this has to be I, then this has to be A inverse only. So whatever elementary row operations I'm going to do in the left hand side, same thing I'll be doing it in the identity matrix, so that once I convert this into complete identity matrix, this whatever result I will get, that will become the A inverse. So let us start. First thing is, if I have to convert it into this 3 into 1, then I need to divide the complete the new row 1 should be existing row 1. This I need to make it from 3 to 1. That means I need to divide 1 by 3 times of row 1. That will be the first step. So what we are trying to do is, we are trying to convert this 3 to 1. So what will happen then? Will be equal to something. Since we are not changing anything in row 2 and row 3, we will be writing the same elements in row 2 and row 3. But only the first row will change. We will do that change, what it is. We are going to divide the entire row by 3. So that means first one will become 1. Next will become minus 1 by 3, and then minus 2 by 3. Here it will be 1 by 3, 0 and 0. So that will be the first step. Then subsequently, you need to convert these elements, that is the first element in second row and the first element in the third row, we need to convert to 0. So how do we do that? So we will have new row 2 is negative 2 times row 1 plus row 2. Why I am doing that? If I multiply this first row by by minus 2, this will become negative 2, and then if I add, this will become 0. So that is the reason. So it is easy to identify what element we are targeting. This element we are targeting to convert 0. Since already this is being made 1, so we will take the opposite sign of this number, which is negative 2. Same way, same logic we'll be doing now. New row 3 will be minus 3 times row 1 plus row 3. So based on that, if we apply this rule, or if we apply this operation to these two matrices, left hand side and right hand side, then we will have, first row will not change. First row will be 1 minus 1 by 3 minus 2 by 3. Here it is 1 by 3, 0 and 0. Then the second one, first element will become 0. We had seen that. Then second element, if we apply this particular rule, which we are actually multiplying negative 2 into negative 1 by 3 becomes positive 2 by 3. Positive 2 by 3 plus row 2. So it will become simply positive 2 by 3. Likewise, this will become 1 by 3. Same operation we are going to do in the unit matrix, that is in the right hand side also. And that will become minus 2 by 3, 1 and 0. Now, this is actually new row 3, sorry. So new row 3 is negative 3 times R1 plus R3, which means 1 into minus 3, which is minus 3 plus 3 becomes 0. And then minus 3 into minus 1 by 3, minus into minus plus, and it is 1 only. 1 minus 5 will become minus 4. And then minus 3 into minus 2 by 3, minus into minus, it is plus, and you will get only 2. 2 is getting added with 0 to get 2. Now, minus 3 into row 1, which is 1 by 3 into minus 3, which is minus 1. Minus 1 plus 0 will become minus 1. And then minus 3 into 0 plus 0, which will be 0 only. Minus 3 into 0, which is 0. 0 plus 1 is 1 only. So that is being done. Now, the next thing is, next step is, you are supposed to make this element as 1. So for that, what we will do is, new row 2 is 3 by 2 times of row 2. If we do that, that will become 1. That is our idea. So this matrix will become, see, we are not doing any change in row 1 and row 3. That will remain as it is. So here also, row 1 and row 3 will be the same. 0, minus 4, 2. Here it is minus 1, 0, 1. Now, applying this operation in this row, second row, we have 0, and then this will become 1, and this will become 1 by 2. And here it will be minus 1, 3 by 2, and then 0. Now, the next step is to make this element as 0 and this element of 0, for which that means we are going to change the new, we are going to change the existing row 1. So we are calling it as new row 1 is equal to 1 by 3 times new row 2 plus row 1. That is for our new row 1. And then new row 3 will become 4 times new row 2 plus row 3. I'm sorry, not new row 2, it is row 2 only. 4 times row 2 plus row 3. Here also, I'll remove that new word. Yeah. So based on this, if we apply, we are changing row 1 and row 3. So second row will be as it is. The first row, if I start applying that operation, I will have 1, 0, minus half. And here it will become 0, 1 by 2, and 0 times A. Similarly, the new row 3 will become now 0, 0, 4. And here it will be minus 5, 6, and 1. So next step is to make this 4 to 1. That is what we will be doing. So that means first row and second row will remain as it is. So first row 1, 0, minus half, 0, 1, half. Here it is 0, 1 by 2, 0, and minus 1, 3 by 2, 0. Here, once we apply this operation, that is the operation is new row 3 will be 1 by 4 times of row 3, existing row 3. So that means we are dividing or we are multiplying by 1 by 4 all the elements 0, 0, 1. Here in this minus 5 by 4, 6 by 4, and 1 by 4. Now, next step is to make these two elements as 0. Means we are going to evaluate what will be our new row 1, something times row 3 plus row 1, and then new row 2 will be something times row 3 plus row 2. What is that something? As we already spoke about, if I am targeting this, I have to take the opposite sign of it. So here I am targeting this. So I need to take the opposite sign of that, which is negative half. So now applying that, we will have, means our row 1 and row 3 will be changing, but row 3 will remain as it is the same. So we will copy that row 3 as it is, minus 5 by 4. 6 by 4 can be written as 3 by 2, and this is 1 by 4. So now we had 1, 0, 0, because once I apply the rule, the operation, I will have this 0, 1, 0. This side, it will become minus 5 by 8 and 5 by 4 and 1 by 8. Same, applying this means half times R3. Half times R by R3 means it is minus 5 by 8. That is why it is getting added to 0. That's why I wrote minus 5 by 8. And then half times 6 by 4. 6 by 4 is nothing but 3 by 2. We already saw that. If I do that multiplication, I will get 3 by 4. 3 by 4 plus 1 by 2, I will get 5 by 4. And then 1 by 2 into 1 by 4, which is 1 by 8. 1 by 8, if I add with 0, I will get this 1 by 8. So based on whatever we decided, that is being applied here, and to get this. Same way, this one, if I apply, I will have minus 3 by 8 and 3 by 4 minus 1 by 8. So now already this has become identity matrix is equal to, this is A, that means this has to be definitely A inverse. So now, therefore, A inverse will be, let's rewrite that, minus 5 by 8, 5 by 4, 1 by 8, minus 3 by 8, 3 by 4, minus 1 by 8, and then minus 5 by 4, 3 by 2, 1 by 4. That will be the inverse of A based on elementary operations using row elementary operations. In case if you find the contents of this video to be useful to you, I request you to please like it, share it with your friends, and also subscribe to my channel. Thank you.